Welcome everybody. My name's Rosie Sheldon and welcome to this webinar. I work for TSG Training and I'll be presenting the webinar today. I trust you can all hear me. Just a bit of housekeeping first. During the presentation, please could you remain on mute, but if you've got any questions, put them in chat or hang on to them and we'll have a question and answer session at the end. I'll be talking today about the Introduction to Test Engineering course. And if you want to know more, please do contact us. The next courses are on the 26th of January and the 25th of May. This webinar is being recorded and it'll go straight onto our website shown here, tsg-training.co.uk. First, I'm going to introduce the course and explain how it fits alongside other courses. And then I'm going to show you various course topics and pull out some interesting bits to give you a taster. And as I said, at the end, there's a summary and time for questions. So, the Introduction to Test Engineering course is a valuable first step if you're either interested in moving into testing or have just started in the field. It's a good way to have a practical introduction to testing, with lots of hands-on exercises with time for support as needed and discussions. And it naturally leads on to other courses, typically the ISTQB Foundation Certificate in Software Testing, which is the starting point for the certified ISTQB journey as shown here. Or maybe for other courses, like the ISKI Certified Selenium WebDriver Foundation Tester or Scrum Master Pro, or other more advanced test technique courses, all from TSG Training. This course is appropriate for apprentices, people new to testing, and others seeking cross-functional training. The Intro to Software Engineering is a two-day course, and it uses slides and discussions and demos and exercises to cover the content. The course provides a thorough grounding in structured and systematic test techniques, which can be applied throughout the software development life cycle, whether that's a traditional one that you're using or agile or DevOps. And we'll begin with those techniques that can be applied at the start of the development project, on the requirements and on the user stories. And we'll continue with those that can be applied while the developer's writing the code, so that the code quality can be improved when it's most cost effective to do so. We'll also be looking at techniques which can be applied once the code's been checked in for test, and explore those suitable for use at the system testing and for using at user acceptance testing. And finally, we discuss and give a demo of test automation before looking at the topic of defects. And, which might be an advantage for you, there's no exam. So a big part is about the specification-based testing techniques. They're also known as black box techniques, and some of them are covered in other courses as you'd expect, but this course provides you with a solid introduction. Gives an exercise for each of these to bridge between learning and work in practice. Now, to use a specification-based technique, you need a specification, a requirement, an agreement on how it's going to work. And I'm now going to give you a mini lesson in the classification tree as an example. So, the classification tree method is a technique for identifying test input scenarios. The analysis only considers all the possible inputs, and the method describes the attributes of these inputs in terms of a hierarchical set of classifications and of classes. And it usually makes more sense with a worked example. So let me show you that now. So here is the problem. Got a factory. It makes tiles, decorative wall tiles. And the quality control system uses a camera to scan the tiles as they come out the kiln on a conveyor belt and identify potential rejects. And we're interested in testing the software that receives the images sent by the camera. Now, these tiles, they can be different sizes, different shapes, different colours, and the current order has asked for a mixture of large and small and isosceles triangles and squares and circles and equilateral triangles and scalene triangles. We've got the problem. How can we use classification tree method to support the analysis? Well, for the analysis, we'll look at the variables that change for the tiles. It's said that the tiles that are produced by the kiln can have varying sizes and shapes, and that they could be different colours. So colour is an example of classification. So these are the attributes. They become the classifications. And these classifications can be broken down into classes, as you can see. These classifications are also known as branches, and the current order has asked for a mixture of sizes, both large and small, and these are classes, and the shapes being squares and circles and triangles. And the shapes can also be different colours, red, green, or blue. So blue is an example of a class. So the text in bold, that's the classifications, and the bullets under them, those are the classes. But actually the current order specifies 3 different types of triangle: isosceles, equilaterals, and scalene. So the triangle shape is a subclassification, a branch too, as it can be further broken down into the classes: equilateral, scalene, and isosceles. Now, if we rearrange these into a picture, we'll get a hierarchical arrangement, and that is the classification tree. So the tree has got to have more than one classification at the top level, just as before: size, colour, and shape. And each class must belong to a classification. So red, green, and blue are classes, and they belong to the classification colour. But do you remember I was saying earlier about triangle being a subclassification of shape? And so now shape has the classes of circle, equilateral, isosceles, scalene, and square. And only one class from each top-level classification family can be combined. So I'm going to show you now how we can do this combination. We can have one from size, a class from colour, and a class from shape. That will be one test. It's about the input analysis. So we're trying to create test cases. So we're going to create a matrix by dropping a vertical line from each class. And then we're going to add each test case a row at a time. So there's test case 1. We've got small is the class taken from the classification size, red is the class from the classification colour, and circle the class from the classification shape. That's one test case. And then we keep going like this. And can you see that we're working through the classes under shape? So the minimum number of test cases required is calculated by counting the number of classes in the biggest top level classification. So the biggest top level classification here is shape. So here we've got 5 tests, make up the minimal test set. Now, a minimal classification tree method test set might not be adequate if the risk is high. Here, it's only 5 tests. And it's up to the tester to choose which combination of small and large you want, because once you've covered small and large from size once, it doesn't matter which one you select for the latter tests 3, 4, and 5, as you can see. The maximal set of tests is created by making sure that all the permutations of combinations of classes in the top level classifications are used at least once. All the permutations. So the maximum number of tests required can be calculated by multiplying together the classes under each classification. So here it's 30 tests because there's 5 classes under shape, there's 3 classes under classification, colour, and there's 3 classes under size. So 5 times 3 times 2, there's 30 tests. But we still need to work out the expected result for these tests before, and then the test design will be complete. So that's the classification tree method. So, in summary, this course is 2 days. It's a Starter for 10 course. It gives you a practical introduction to testing. And we talk about static testing and continuous integration and testing at the developer level. And then we practice and use specification-based testing techniques. We talk about user story testing. We talk about automation and raising and managing defects. So it's a kickstart to a testing career. Other courses might also be applicable, maybe now, maybe later. So please, if you've got any questions, do ask. Otherwise, thank you very much for joining me, and look forward to seeing you on this course or any others at TSG Training. Thank you.